Finally, NASA unsealed the capsule containing the largest asteroid sample ever collected by a space mission. Hello everyone, welcome back to Zeey. In this video, we will see what scientists have found from the inside of OSIRIS-REx capsule. If you are new to the channel, hit the subscription button and ring the bell so you won't miss any update. The sample originated from Bennu, a potentially hazardous asteroid that resembles an early solar system time capsule. On September 26, 2023, NASA's Johnson Space Center in Houston unsealed the sample-returned canister of the OSIRIS-REx mission, which had returned to Earth with an asteroid sample 2 days earlier. As the lid was lifted, the scientists were shocked to discover a layer of black dust and detritus on the avionics deck of the container. In addition, the sample was 100 grams heavier than those collected at Bennu. This was unexpected, as the sample was kept in a sealed container throughout the entire journey. Then how did it occur? What is the origin of the unanticipated black dust on the canister's avionics deck? Lastly, and most importantly, what do scientists anticipate discovering in the comprehensive analysis of the largest asteroid sample ever brought back to Earth? OSIRIS-REx was initiated on September 8, 2016, with 3 primary objectives. The initial step involved sample collection. The mission's objective was to acquire pristine samples from the asteroid's surface so that scientists could examine and comprehend the composition of primitive asteroids. The second was the characterization of asteroids. Astronomers desired to understand Bennu's geology, so the mission was tasked with mapping the asteroid's surface, determining its composition, and assessing its potential as a resource for future space exploration. Assessment of Earth's impact hazards was the third and final objective. As stated previously, Bennu is a potentially dangerous asteroid. Bennu will pass near to Earth on September 25, 2135. Bennu's future trajectory is difficult to calculate due to our planet's gravitation, which will alter its path. In addition to gravity, asteroids can also be moved by non-gravitational forces such as the Yarkovsky effect. The day side of a rotating asteroid is heated by sunlight. As the asteroid rotates, the night side cools and radiates heat. This exerts a minor thrust on the asteroid, causing it to alter its course over time. The Yarkovsky effect is difficult to model, but it can have a substantial impact on where asteroids wind up. Because we do not know precisely how the Yarkovsky effect will perturb Bennu's orbit, our knowledge of its location as it approaches Earth in 2135 is limited. Therefore, scientists must evaluate a variety of potential trajectories, depending on the force exerted by the Yarkovsky effect on Bennu. A small number of these trajectories align with regions of space known as gravitational keyholes. If Bennu were to pass through a keyhole, the Earth's gravity would deflect its path precisely enough to induce an impact on a subsequent orbit in the late 22nd century. Although the likelihood of this occurring is quite low, scientists want to know as much as possible. The journey to Bennu lasted 2 years and 4 months. OSIRIS-REx arrived at its destination on December 3, 2018, after traveling approximately 1.4 billion miles or 2.2 billion kilometers. It entered orbit around the asteroid and commenced a series of surveys and mapping operations to determine the best location for sample collection. The most exciting phase of the OSIRIS-REx mission occurred on October 20, 2020, when samples were collected. The spacecraft used its touch and go sample acquisition mechanism, or TAGSAM, to acquire the sample by briefly touching the surface. TAGSAM is a robotic arm attached to the primary body of the spacecraft that collects an asteroid sample and transfers it to the Earth return vehicle. Since Bennu is a small asteroid with a diameter of only half a kilometer, the sample had to be collected in nearly negative gravity. OSIRIS-REx had a single opportunity and there was no room for error. When the spacecraft finally made contact with Bennu at the Nightingale site, surface material was agitated and lifted into the sample collection chamber using a nitrogen gas explosion. Minimum sample weight requirements were 60 grams. OSIRIS-REx collected 300 grams of the sample during the fleeting 9-second encounter with Bennu. This is 5 times what NASA expected. The material was escaping due to a flap being blocked by larger rocks. To prevent further loss, NASA skipped the sample's scheduled measurement and sealed it for return. On May 10, 2021, OSIRIS-REx departed Bennu and began its journey back to Earth. After nearly 2.5 years, on September 24, 2023, the spacecraft reached the vicinity of Earth and discharged the asteroid sample capsule. The capsule entered the atmosphere of our planet at a velocity of 12 kilometers per second and deployed a parachute to halt its descent. NASA personnel recovered the capsule from the Utah Test and Training Range where it landed safely. A few days later, scientists at NASA's Johnson Space Center in Houston removed the lid from the OSIRIS-REx mission's sample return canister. They were greeted by a sight that astonished and enthralled them. On the avionics deck of the sample canister that most likely belonged to Bennu, they first observed a layer of dark powder and sand-sized particulates. This dust coated not only the interior but also the exterior of the canister, including the avionics deck where the electronics were contained. The canister's dust escaped through microscopic holes between the lid and the body. The obvious query is, how did this occur? NASA believes that OSIRIS-REx's brief contact with Bennu's surface upon touchdown generated a shockwave that spread across the asteroid's surface, culminating in the ejection of certain materials into space. Some of this material trailed behind OSIRIS-REx as it retreated from Bennu and adhered to the spacecraft's outer surfaces. In addition, a portion of it entered the sample container through the open cover and mixed with the taxon collected material. The aggregate mass of the sample, including the dust and debris, is approximately 400 grams, which exceeds their scientific objectives. In addition, the sample reportedly remains in pristine condition due to minimal exposure to high temperatures or contamination during its return voyage. The presence of grime and debris on the avionics deck, however, presents a unique obstacle. It requires cautious handling and cleaning by scientists employing specialized equipment and methods. They intend to clean the deck without causing damage to the electronics or losing any material. Additionally, they must meticulously document and catalog each fragment of dust and detritus since they are integral components of the sample inventory. This example return mission is a momentous occasion. However, why do space agencies spend billions of dollars to visit space objects that are barely a half-mile wide? The reason for this is that asteroids are time capsules. They originated in the early solar system when the planets were still in the process of formation. Asteroids are composed of the same substances as planets, but they have not been altered by plate tectonics or other geological processes. This enables the preservation of a record of the early solar system that cannot be found on Earth. Scientists have discovered, for instance, that asteroids contain diverse organic molecules. These molecules are believed to be the building elements of life, and their presence on asteroids suggests that the early solar system contained the necessary ingredients for life. Particularly intriguing is the discovery of organic molecules on the asteroid Yugu. As a carbonaceous asteroid, Yugu is abundant in organic matter. Hayabusa 2 returned samples from Yugu to Earth in 2020, and scientists have since analyzed these samples and discovered a variety of organic molecules, including amino acids. Proteins, which are necessary for existence, are composed of amino acids. This suggests that the constituents for life may have arrived on Earth via asteroids in its early history. The next phase of the OSIRIS-REx mission, renamed OSIRIS-APEX, will examine the asteroid Apophis. Apophis is a near-Earth asteroid with a diameter of approximately 340 meters or 1,100 feet. It will make a close approach to Earth in 2029, and there is a 1 in 150,000 possibility that it will collide with Earth in 2068. In April 2029, only a few months after Apophis's close approach to Earth, OSIRIS-APEX will arrive at Apophis. The orbiting spacecraft will spend 18 months researching Apophis. OSIRIS-REx will use its instruments during this time to image and map the asteroid, analyze its composition, and determine its size and shape. The OSIRIS-REx mission is essential to our comprehension of near-Earth objects and the hazard they pose to Earth. The mission's data will assist us in protecting the planet from asteroids. Alright guys, this video ends here. Thanks for watching. What are your thoughts? Is there anything you'd like to say? Tell us in the comments, subscribe, and I will see you soon.